So welcome back. So after calculation of area by different methods, we are getting into calculation of volume. Okay. So in that we are getting into calculation of volume using cross sections. Cross sections, just that one. Okay. And typically we are examining canal sections or embankment sections. Okay, so canal section is if this is the initial ground level, we will be cutting a canal like this. That is a canal section. Okay, so we will be removing this earth out and we will be getting a surface like this. And embankment is there will be a ground level like this, and in that we will be depositing a trapezoidal form of earth, and in here we will be laying roads or electric lines or railways. Okay, all those things can be done. So these two are the most forms of civil structures where movement of earth is coming into place. That's why we have to calculate volume. Okay, so for cutting of a canal, you have to calculate how much volume of earth you will have to remove from that line of canal. For embankment, you will have to calculate how much amount of earth should be deposited into that point. Okay, you get the importance of that one. So we are calculating the volume, and for that volume we will be taking some measurements, and in that measurements this is called B. B is called constant formation width. Okay, in that we will be equivalent here also, same thing at the top, here in the top and here at the bottom, constant formation width, and there will be a depth in this case and there will be height in this case. For both we will be terming it as h, height h. Okay, and for canal section it will be depth of cutting. Okay, so for embankment you know that height of deposition. Let it be depth of cutting for further. So B, H, there is a slope in here. Okay, and that slope is given as n to 1. N to 1. That is, n to 1 means for n horizontal there will be 1 vertical. That's it. That means we suppose this is 1 meter and this is n meter. If n it is given as 5 to n, 5 to 1, that means this distance is 5 meters. Okay, we have to get for this straight slope, this will be a straight line, 5 meters of horizontal distance should be taken to get 1 meter vertical distance. Okay, if it is 1.5 to 1, that means it is 1.5 meter of distance, horizontal distance, to get 1 meter vertical distance. Okay, so those are the parameters N, B and H. Okay, so how do you calculate this volume? And be attentive. If suppose this is the length of It's a representation of length of canal, total length of a canal section. The cross section is like this, okay, with H in here, B in here, and N21 in here. Okay, so pay attention. This is the total length, and the volume to be calculated is this form of shape. The earth inside this shape should be calculated as volume. Okay, so first we will be taking cross sections. Okay, so before that, this method that we are going to tell you is very similar to offset method, offset and baseline method with regular intervals that we had studied in area calculation. Okay, so it is very similar. There is a slight change. Instead of offsets, we will be taking areas. That's it. Okay, so consider this as the total line, and instead of offsets, we will be taking areas at regular intervals, like this. A1. If this cross section, if as it is the method is known as cross sections, we will be taking area of this cross section and it will be naming it as A1. We will be taking this cross section and we will be taking it as A2, and this one A3, A4, A5, A6, A7, A8, etc. It can end up to AN, again number of cross sections. Okay, so you calculate, first you calculate the area by area of the cross section of each cross sections, then you substitute it into our Simpson's rule and trapezoidal rule. Okay, that's how you calculate volume. Okay, so I hope you get it. You will be calculating cross sections as A1, A2, A3, A4, A5, A6, etc. AN. Then you will substitute this area of cross sections into our old trapezoidal equation and Simpson's 1/3 equation. Okay, so how to calculate the area of cross section? The cross section is just this. This is the formation width. This is the depth of cutting. Side slope is n to 1. Okay, so area is equal to, equation for area is equal to B plus NH into H. That's how you calculate the cross sectional area of this level section. This is called as a level section because you are having a level ground surface. Okay, so B plus NH into H. We know what are B, N and H are. Okay, so as next step you will be calculating A1, A2, A3, A4, A5, A6, etc. Then as a result, as I said earlier, you can have two equations. First one, trapezoidal equation. You can calculate volume by two methods. First one, trapezoidal equation. Volume is equal to the same thing. D is the interval of each cross sections. Okay, D into A1 plus AN N1 divided by 2 plus A2 plus A3 plus etc. AN. Okay, so it's the same equation. Instead of O, we are substituting A, areas. D into A1 plus an divided by 2 plus a2 plus a3 plus etc. an. And we have one more equation, Simpson's equation, but in this case in modeling calculation it is known as Trapezoidal equation. Trapezoidal rule, and equation is the same. Volume is equal to d by 3, d is the constant interval, d by 3 into a1 plus an plus 4 into same equation. Instead of a0 at starting, we started with a1, that's the only difference. 4 into all the even number of areas, a2 plus a4 plus etc. a n minus 1 plus 2 into a3 plus a5 plus a7 plus etc. plus a n minus 2. That's it. That's how you calculate volume using trapezoidal equation and Trapezoidal rule. Same equations, just instead of O we are substituting with A, and A values will be calculated by this equation, B plus NH into H, where all these B and H values will be getting from that level section, and there will be a interval D. Okay. So we are having a problem. Okay, a railway embankment. Railway embankment will be looking like this. As we said in embankments, this is railway embankment. Okay, this was the initial ground level. All this trapezoid was filled by earth, and railway will be running on the top point. Okay, and we know top portion is called as D, height is known as H, and slope is known as n to 1. Okay, obviously the question is to calculate volume. Okay, so now you can assess, we'll assess the values given. Wide width, railway embankment is 10 meter wide, that is, this is 10 meter. Width of railway embankment is 10 meter, and with side slope 1.5 to 1. 1.5 to 1, that is n is equal to 1.5. B was 10. Okay, and assuming the ground to be level in a direction transverse to the center line, this ground is level. Calculate the volume contained in the length of 120 meters, that is total length is 120 meters. Total length is 120 meters, that is ND, or number of divisions into difference in level. The center heights at 20 meter intervals being at meters, that is, if you know, if this is the figure of section, okay, 20 meter intervals, that is 20, 40, 60, 80, 100 and 120, 20 meter intervals. Is given, height is given. So for calculation of area, you know the equation is area is equal to, cross sectional area is equal to B plus NH into H. Okay, in that we have B, we have N, the only one we are not having is h, and that is different for each sections of railway embankment with constant interval 20 meters. Okay, that is given in the question as 2.2 at 0, 2.2, 3.7, 3.8, 4.0, 3.8, 2.8 and 2.5. Okay, so you have 1, 2, 3, 1, 2, 3, 4, 5, 6, 7 values, 7 cross sections to find out an area of, and after finding A1 to A7, we will be substituting these A1 to A7 values to Trapezoidal equation and Trapezoidal equation. Okay, even if you are not asked separately or any method in particular, you have to do both problems. Okay, both equation, both rules. You have to find volume twice using trapezoidal and prismoidal. Okay, even if it is not asked in the question. Okay, so for each of the sections, B is same, N is same, total length we know, just H is different. Okay, so we can calculate A1 is equal to B plus N H1 into H1, that is 10 plus 1.5 into H1 is 2.2 into 2.2, that is 29.26 meter square. Okay, so A2 is equal to B plus N H2 into H2, that is 10 plus 1.5 into 3.7 into 3.7. A3 is equal to 10 plus 1.5 into 3.8 into 3.8. A4 is equal to 10 plus 1.5 into 4 into 4. A5 is equal to 10 plus 1.5 into 3.8 into 3.8. Same with A3. A6, A7, A6 10 plus 1.5 into 2.8 into 2.8. A7 10 plus 1.5 into 2.5 into 2.5. Okay, so you found A1 to A7, then you substitute in the equations that we mentioned in the theory class, then find out direct question. There is no twist on that. And one more thing to notice, that as in area calculation, for using prismoidal rule, clearly just with prismoidal rule you need even numbers of divisions. Okay, so in here we have 1, 2, 3, 4, 5, 6. Okay, so 1, 2, 3 sections. So that's okay. There is no need to calculate one section by trapezoidal equation. Okay, so you can just substitute those values A1 to A7 in prismoidal equation and trapezoidal equation. You will get the answer. If suppose you had one more section like this, that the one we did like in 3.1, no, in area calculation, if suppose you had 1, 2, 3, 4, 5, 6, 7th value, then again you will have to calculate till 6th volume. You have to calculate by prismoidal formula, and this one will be calculated by trapezoidal formula and add with prismoidal formula. Okay, as we did in area calculation. Okay, I hope you get the calculation of volume and calculation of area. It is very similar to calculation of area. This cross section method, you just find the cross section and substitute all the cross sectional values in prismoidal and trapezoidal area. Okay, thank you.